Hey guys, what's up? Manas here, and this is going to be problem number 2 in section of solids, and it goes like this. A square pyramid, base 40 mm side and axis 65 mm long, has its base on the HP and all the edges of the base equally inclined to the VP. It is cut by a section plane perpendicular to the VP, inclined at 45 degrees to the HP and bisecting the axis. Draw its sectional top view, sectional side view and true shape of the section. Alright, so guys, answer the following and you're on your way to constructing. So the object here is a square pyramid. Fine. Now this particular square pyramid is having a base of 40 mm and the axis length is 65. Alright, so base of 40 mm, whereas the length of the axis or the height of the square pyramid is 65 millimeters. Fine. Now then, and all the edges of the base equally inclined to the VP. So this is the condition and it should reflect in our drawing. All the edges of the base equally inclined to the VP. So when in totality there are 4 edges in the base. Now if all of them are to be equally inclined to the VP, then you have to ensure an angle of 45 degrees. If you ensure an angle of 45 degrees, then you'll observe and you'll realize that automatically each one of them get inclined at an angle of 45 degrees. Alright, so this is what equal inclination does, and it only happens at a certain angle, and that angle in fact is 45 degrees. You'll come to know, I'll tell you in drawing. Alright, the next thing is regarding the cutting plane. So it is cut by a section plane perpendicular to the VP. So guys, if you have a plain piece of paper and if you hold it in such a way and keep it absolutely perpendicular to the vertical plane, that is wall in front of you, and when you look at it from the front, you will observe a straight line. Okay, you can tilt it, but still it is going to be a straight line. So our straight line is nothing but a cutting plane which we're going to place it in the front view, making a certain angle and bisecting the axis. These are the conditions which I'll be ensuring. So the cutting plane is inclined at an angle of 45 degrees. So this over here is 45 degrees. Fine. The position of cutting plane. So the cutting plane is actually bisecting the axis. Alright. So I'm going to write over here bisecting the axis. Bisecting the axis. And in order to quantify this, I'll have this height is 65 millimeters. So this is going to be 32.5 mm above XY line. So this is how you need to go about your task. Now, starting, the main issue in any question of section of solids or projection of solids is the start. And if you start well, you're going to end up doing well. Alright, so we have this object positioning. All edges of the base are equally inclined to the VP and resting with its base on HP, that is horizontal plane. So we have this square pyramid. So you can see this square pyramid. It has the base that of a square. This base is 40 mm each, and the square pyramid is such it is resting with its base on horizontal plane. Now guys, if it is resting with its base on horizontal plane, then one thing is for sure, that the true shape of the base can be seen from the top. Okay, so you have to start by drawing the top view first, and then accordingly its front view is going to be made. Alright, fine. So let's begin. Okay, so I'm gonna start by drawing this top view. So this is 40 mm, 40 mm, 40 mm, and again 40 mm. Alright, now you guys might be wondering that why I have drawn this figure. Okay, now if you can clearly see that this over here is the vertical plane above XY line, and below XY line we have this horizontal plane. In the horizontal plane we have the top view, and over here, that is in the vertical plane, we are going to have the front view. Now this particular top view, it's showing that the two edges are absolutely parallel to XY line. That means they are parallel to VP, and these two edges have been placed such that they are perpendicular to the vertical plane. Okay, but in the question it has been clearly mentioned that all the edges of the base are equally inclined to the VP. So what I'm going to do is Please follow the steps. Okay, I'm going to rotate this figure by an angle of 45 degree. All right, now you can see that all these I'm going to show you by dimensioning. That will be much better. This is 45. Everywhere all the edges are equally inclined to the vertical plane. It can be seen. Okay, so this is how you need to initially make your top view. Okay, by making an angle of 45 degrees with the xy line, and eventually it's going to end up making equal angles with the vertical plane also, and that angle in fact is 45 degree. All right, now guys, I'm going to start with naming these four corners. Let's say this is point 1, this over here is point 2, and this over here is point 3, and this guy over here is point 4. So there is going to be a center over here. Okay, so this is going to be a pyramid, and all the points are connected to a common point over here. This is what you call the apex. So in order to find the apex, let us draw these two lines. Okay, and from 4 to 2. So this is exactly how a square pyramid would look like. Okay, and I'm going to write over here, I'm going to write O. That's it. Fine. Now so this is the top view. We have begun with the top view, and then correspondingly we're going to make its front view. So let us start. All right. Okay, now when you are going to see this square pyramid right from the front, you are going to observe its axis length or the height of the square pyramid, and its height is given as 65 millimeters. So I'm going to go 65 steps upstairs, and then I'm going to join it with this point, this point, this point, and back to the apex. All right. All right, now if you want to check the dimensions, you can do so. This over here is 40 millimeters, and this over here is 65 millimeters. All right, now these are the points exactly at the base. So one is going to be here. So this is 1 dash. This point is 2, and behind 2 we have 4. So over here I'm going to write 2 dash comma 4 dash. All right, and over here we have point 3 dash. That's it, guys, and we have the apex in the form of 4. This is the top view of apex, and this over here we're gonna have point O dash. That's it. All right, so I'm going to delete this dimension for a while, and then we're gonna locate the cutting plane first. All right, so let us see what has been given to us regarding this cutting plane. Okay, it is inclined at an angle of 45 degrees theta. Okay, that means this cutting plane is making an angle of 45 degrees with HP, that is horizontal plane, and it is bisecting the axis. Okay, so what I'm going to do is, you need to take a center of this line over here. This line, you see, you need to take its center, and from this point you need to make a line at an angle of 45 degrees. Okay, something like this. I'm going to show you. Yeah. That's it. So this is our cutting plane. It has to be made dash dot. Okay, and has to be darkened. That's it. Now all the portion of the solid coming below the cutting plane has to be darkened. So let's get this done. Okay guys, that's it. Now let's dark this portion. Okay, so this is the portion of solid which is remaining. Okay, the remaining the portion above the cutting plane, this so-called cutting plane, section plane, has been cut off. Okay, now next my job is to find the intersecting points. So there is an intersecting point over here. Okay, so let us say this is this is going to be point A dash. Okay, and its corresponding top view is going to be somewhere here. So that's A. So I'm going to write A over here. Okay, then we have this. So it may appear as if there is only one slant edge over here, but in reality there are two slant edges. One is O2 and behind O2 there is O4. All right, O2 and O4. Okay, so we're gonna have 2 points. Let us say that this is C dash, and let's say that this is B dash, and over here we're gonna have point D, obviously D dash, front view. Now D dash's top view is going to lie somewhere here. So guys, this is going to be point D. Okay, so if this is D, this is D dash. All right, now the issue is, if I extend a line from here, it does not cut anywhere. Okay, and in order to solve this problem, in order to locate point B and point C, now point B is going to lie somewhere here and point C is going to lie somewhere around here, along this line O4. All right, so in order to do so, we have a small solution towards this. Please watch this carefully. Let us bring a horizontal line, not like this, and bring it below until it intersects this O3 line somewhere around here, and then we've got to do a small construction. Remember, taking O as center and with this as the radius, this point as radius, you need to turn it, and it is going to intersect it somewhere here. That's it. The same process has to be done in the clockwise sense also, with O as center and with this point and this point as radius. You need to turn it clockwise. Okay, and it should look something like this. That's it, guys. That's exactly what is supposed to be done. Now this point over here is what you call point B, and this over here is what you call point C. Now we're going to join all these points A, B, C and D, and that is going to be our sectional top view starting from here, that is A, and ending at D. All right, so let us join all these points and let us get the final sectional top view, the C, A, B and back to D. All right, let me hatch this and let me darken it up. Let me pick the points. That's it, hatching done. Next thing to do is to darken this portion again. This is the remaining portion. Okay, all right, stuff that is left is, now guys, please look here, from A dash to 1 dash, it has been joined with the help of a dark line. So A1, its top view, corresponding top view will be dark. Similarly, from B to 2 and C to 4 and B to 2, we need to dark this also, and we need to dark this also from D dash to 3 dash, and hence its corresponding top view also has to be darkened from D to 3. It should look something like this. Please watch this carefully. From D to 3 we have a line. Again we have a line from C to 4. Again we have a line from B to 2, and we have a line from A to 1. That's the line, this one and this one, and let us finally darken this up. That's it, guys. So that's exactly how the sectional top view will look like. Okay, so I'll write over here, this is what you call front view, big and bold, front view, and this is what you call sectional top view. Now the next thing is to create a sectional side view, but before that we're gonna focus our attention towards this, what you call sectional side view. Okay, and for creating the sectional side view, I need to look at this object exactly from here, okay, at an angle absolutely perpendicular to this cutting plane. All right, so in order to do so, we are going to have a line over here, and this particular line is going to be not so dark, it's going to be a simple line. Okay, now this line over here is, this is X, we've already taken X, and this is going to be X1, and this is going to be y1. Let me shift this front view a little. All right, now we need to draw perpendicular lines from these intersecting points. Okay, so there are 1, 2 and 3. So this point represents 2 different points. All right, so there are going to be 3 lines from here, and it's going to be absolutely perpendicular to this one. So what you guys can do is you can keep one scale of your drafter along this line so that the other scale becomes absolutely perpendicular. Tighten the screw, then keep on drawing lines and move parallel. All right, so let's do this. So let us start by drawing these horizontal lines, so let us start by drawing these so-called perpendicular lines. All right, so we have already done by drawing a line from A dash. So let's do it for B dash, C dash and for D dash. So these are the 3 lines. Okay, next step, it's quite simple, and if you have seen my previous video on section of solids, then it should be a cakewalk for you. Okay, we're gonna take, for locating point A, we have to take this arc right from here until here. All right, and let's see what the length of this arc is. You guys just need to keep your compass to the you guys just need to keep the 2 legs of your compass, one over here and the other over here. That's it. That is going to be your arc. So the arc length is 54. All right, what I'm going to do is, with this as center and an arc length of 54, I'm going to put an arc. That's it. So this, guys, this over here is what you call, this is going to be my point A. Big and bold, done. Now let's locate point C. For point C, let's see how much this arc length is. So this is working out as 40. All right, again the same stuff. 40, an arc of 40. All right, so this is going to be point C. Now let's worry about this point B. So for point B, we have this arc, an arc length of 68. All right, and here I'm going to put it, I'm going to write, this is in fact B. All right, only one point is left, and that is point D. Let us fix this also first of all, but let us see how much this arc length is. Okay, you guys can make use of a compass, rounder, whatever you may call it. This is 54. This is 54. So D is going to lie somewhere here. This is okay, 54. So that's point D for you. Now let us join all these points by a straight line. BD, C, A, back to B, okay. Okay, now let us darken this and let us do the hatching. Pick points, done, hatching done. So this is what you call the true shape of section. Okay, true shape of section. That's it, guys. The next thing to do is to create its sectional side view, and we are going to look at it from here, right from here. Okay, now in order to create this sectional side view, I'm going to draw an absolutely vertical line from here. Oh, what's happening? Okay, so this is going to be a vertical line, and I'm going to write, this is y2, and this over here, this point over here is what you call x2. Okay, so we're going to draw initially these horizontal lines from here. Let us draw them from this point to this point, from this over here till this, from B till it meets x2 y2, and from to this vertical line. All the points have been covered. Now I need to rotate this line by an angle of 45 degrees. So that can be done. Please watch it carefully. Alright. Now let us make more lines of this sort. And you can do so by turning your mini drafters by an angle of 45 degrees. And now I'm going to extend these lines until it intersects this so-called XY line. Alright. Next thing to do is to draw lines from this apex O dash towards the right for the side view, and then we are going to draw these vertical lines. Okay, keep your drafters absolutely vertical and keep on making these so-called vertical lines, 5 in totality. That's it. Now start drawing horizontal lines, first from C dash, this is D dash, then from B dash and C dash, and finally from A dash. That's it, guys. Now let us see what these intersecting points are. As far as this is point A, this middle line over here is for point A, and it is going to intersect in somewhere here. Alright, so here we have, this is going to be point A double dash. Double dash corresponds to side views. It's going to be small letter. Alright. Secondly, we have this point B and C, and for C we have this line over here. Okay, C is going to intersect somewhere here. This is going to be point C double dash, and this is going to be for B double dash. Alright. Now the only point left is point D. This is the middle line over here, and it should intersect somewhere here. This is going to be point D double dash. Fine. Now let us join all these points with the help of a line. C to A, A to B, D, and back to C. Let me darken this. Let me hatch this also. Well, that's it, guys. Now if you see that these base points from the left hand side, to the extreme left we have point 4, and towards its right we have point 1, and then to the right of 1 we have point 2. So 4, 1 and 2. 4, this is going to be 1, and this is going to be 2. Okay, guys, this is 4 double dash, 1 double dash, and behind 1 we have 3. Okay, so this single point corresponds to 2 points, one at the front and the other at the back. That is 3 double dash. And finally we have this point as 2 double dash. Alright, now let us join these points. Let us join them. Alright, from A double dash to 1 double dash. Alright, now let me darken this up. The portion which lies below the cutting plane, okay, which immediately falls below the cutting plane, has to be darkened, and the one above the cutting plane should be left as it is. Okay, one more advice, guys, you need to remember this. Okay, wherever you are darkening, make use of an H pencil, and the remaining drawing can be prepared with the help of a 3H pencil. So this is what you call the sectional side view, or to be more specific, it's the sectional left hand side view. Sectional side view, that's it. And this over here is the center point of this axis, alright, through which the cutting plane passes, and it passes through an angle of 45 degrees. Alright, the distance over here is 32.5, since it is bisecting the axis, and the axis was 65. It is showing as 33 millimeters, but it is 32.5. Trust me, take my word. All right, because it has been rounded up to 0 decimal places, maybe that's why. So all right guys, that was all from my side. This was problem number 2, and I'll be back with problem number 3. If you have any questions, doubts, queries, make sure to write them below in the comment section. This is Manas Patnaik signing off. Take care. Good night.